Come again, and we are going to be looking at the Southwest Regional Mock 2024 Proposed Solution, Pure Mathematics with Mechanics Paper 2. So I'm coming to respond to a student called Magalian who placed a comment that I should look at a question on quadratic equation from the Southwest Regional Mock Paper 2. I am Tata NS, and let us begin right away. So the question is on quadratic equation. I'll read it and we'll see how to solve the question. Given that one root of the equation of 3x squared minus 4 plus 2k into x plus 2k is equal to 0 are alpha and beta. Find the value of k for which beta is equal to 3 alpha. So we have been given a quadratic equation, and the roots of these equations are alpha and beta. And we are asked to find the value of the constant k, given that beta is 3 times of alpha. But first, we need to know some bases before we go ahead solving the question. Now, let's consider this quadratic equation ax squared plus bx plus c equals to 0, where roots are alpha and beta. Then the sum of the root denoted alpha plus beta is equal to negative b divided by a, where b is a coefficient of x and a is a coefficient of x squared. And the product of root alpha times beta is equal to c over a, where c is a constant term and of course a is still the coefficient of x squared. So with this, you can be able to solve this problem to the end. What is needed more is just some basic skills in algebra to be able to transpose and make one variable the subject of an equation. So let us begin. Now, this is the equation here. I'm going to write down the root. The root we're given as alpha and beta, such that beta is 3 times of alpha. This is very important. It will help us later as you are going to find out. Now, let us write out the value of the constants a, b, and c from this quadratic equation. A is 3, b is negative into 4 plus 2k. The mistake that most people do is that they will just take out this term without the negative sign. The term, the constant b is whatever is multiplying x. And in this case, all of this term, including the negative sign, is multiplying x. And of course, c is a constant, 2k. So I have brought out the values of a, b, and c. So I can go ahead and apply all of these that I have just read to you. Now, the sum of the roots, since the roots are alpha and beta, I will take those two roots and I sum them. It must not always be alpha and beta. It can be p and q, it can be r and s, it can be whatever variable or constant they choose to use. But just know that if the roots are given as p and q, then instead of alpha plus beta, you'll be looking for p plus q. So in this case, I just have to add alpha plus beta, which is equal to negative b divided by a. Then multiplying this term in b by a negative 1. Since negative times negative gives me positive, I'm left just with 4 plus 2k divided by a, and a is what? A is 3. So I have alpha plus beta is 4 plus 2k divided by 3. But what do we know? We know that beta is the same as 3 alpha. So I'll come back here and I'll replace beta with 3 alpha. So I'll be having alpha plus 3 alpha is equals to 4 plus 2k on 3. And of course, alpha plus 3 alpha gives us 4 alpha is 4 plus 2k on 3. I can go ahead and I make alpha the subject by dividing both sides by 4. 4 comes and multiply with 3 and gives me 12. In other words, I can multiply each of these terms by 1/4. So alpha will be 4 plus 2k divided by 12. Let me call this equation 1. Now, this is the equation 1. Let me use the other idea where the product of roots, alpha times beta, is equal to c divided by a. C was 2k divided by a, which is 3. But again, beta was 3 alpha. So I'll come where I see beta and I replace by 3 alpha. So I'll be having alpha times 3 alpha is equal to 2k on 3. 3 alpha squared is equal to 2k on 3. Now, I can again make alpha squared the subject by dividing both sides by 3 or multiplying each term by 1/3. So that gives me alpha squared is equals to 2k divided by 9. This is equation 1 over here, and down here we have equation 2. What I'm left to do is just to eliminate alpha from any of these equations so that I can find k. And it's easier to just substitute equation 1 into equation 2 because alpha is 4 plus 2k divided by 12. I can just substitute equation 1 inside of equation 2 in order to eliminate alpha. So let me put equation 1 into equation 2. In the place of alpha, I'll replace this, which is 4 plus 2k divided by 12. All that squared is equals to 2k divided by 9. Now, notice that alpha has vanished from this equation. What I'm left to do is just to solve this equation for the value of k. What I will do is just to multiply out the bracket, that is to expand. Remember, this term squared means I'm multiplying the term into itself. So when I square, I obtain 16 plus 16k plus 4k squared divided by, this square also affects a denominator, and 12 squared is 144. Is equals to 2k divided by 9. At this juncture, I can cross multiply in order to eliminate the denominators. So when I cross multiply, 9 multiplies each one of this term, and 144 multiplies 2k. So I have, when 9 multiplies 16, I have 144. 9 multiplies 16k, I have 144k. 9 multiplies 4k squared, I have 36k squared. Is equal to 144 multiplied by 2k gives 288k. Now notice that this is a quadratic equation in k because the degree of this term is 2 and the variable in this term is k. So I can reorder it by taking all terms to the left hand side. This 36k squared remain on the left hand side. Then I bring this 288k to the left hand side and it subtracts. So I'll be having 144k minus 288k, that gives negative 144k. Then I'm left just with plus 144 is equal to 0. It's true that I can try to factorize this equation as is, but I can try to simplify it to make my work easier because each term in this quadratic equation is a factor of 36. So I can divide each term by 36. Dividing this term by 36, I'm left just with k squared. Dividing negative 144k by 36, I'm left with negative 4k. And dividing 144 by 36, I'm left with 4 is equals to 0. Now let me try to factor out this quadratic equation. The coefficient of k squared is 1. So if I find two factors which multiplies to 4 and add to negative 4, then I am done. What are they? Yes, the factors are probably negative 2 and negative 2 because negative 2 times negative 2 gives me positive 4 and negative 2 plus negative 2 gives me negative 4. So I can just write out the factors as k minus 2 into k minus 2 equals to 0. Then of course these terms are repeating. I can just write it as k minus 2 all that squared is equals to 0. Finding the square root of both sides to eliminate the square, I'm left with k minus 2 is equals to 0 because the square root of 0 is 0. Now I just have to take this negative 2 to the right hand side and k is equals to 2. So the value of k is equals to 2 in this particular question. So Magalian, I hope you have understood. Thank you so much for your patience and thank you for watching to the end, and stay tuned for more videos. See you soon.